Okay, picking up where we left off. The orange graph is the extended basic reciprocal function. Now, we want to look at a couple of other graphs. Now I'll just draw the graph quickly. This will be the reciprocal square function, the basic reciprocal square function. So we're going to put 2 here, put -2 here, put -1 here, 1 here, 1/2, 1/2. Then we need to have 4 up here. Of course, you've made the table, you understand where these numbers come from. And 2 here, and 1 here, 1/2 here, 1/4 here. When x is 1/2, the value of the basic reciprocal function is 1/4, giving us a point here. When x is -1/2, it's also 1/4 because squaring 1/2 or squaring -1/2, I should label that -1/2, gives the same thing, the square being an even function. And I don't know what I just did. I put these at 1/4. Apparently I can't talk and think at the same time. But then, okay, the values at 1/2 and -1/2 are 4, not 1/4. Then we have 1, 1, and -1, 1, and 2, 1/4, and -2, 1/4. And then we can draw the graph of the extended basic reciprocal function. Ends here. And a graph here. So there it is. And of course we've clearly shown the points of the basic function, which are our guides for drawing the extended basic reciprocal function. The basic exponential function is only defined at the integer values, since we can't express exactly the value of the exponential function at non-integer points. So this is the y equals 2 to the x function. Here's 4, here's 2, here's 1, then we have 1/2 and 1/4. Plotting our points, at -2 the value is 1/4, at -1 the value is 1/2, at 1 the value is, at 0 the value is 1, at 1 the value is 2, at 2 the value is 4. Extending these values with a curve. We have the graph of the extended basic function. We put some big dots on the points of the basic exponential function. I think I said exponential before. Not sure. Okay, so there we have it. Now the basic cubing function, quite easy to graph. Now the values have to go all the way up to 8 and all the way down to negative 8. At negative 2, the value is negative 8. We have a point here. Negative 1, the value is negative 1. Well, to find negative 1 with some accuracy, we're going to have to subdivide, from 0 to negative 8 in half to get negative 4, divide that in half to get negative 2, divide that in half to get negative 1. So here is negative 1. Now that kind of interferes with the label of 1/2. It's a little small. Should be legible if you're on full screen. Okay, so we have negative 8. At negative 2, negative 8, there's the point. Negative 1 is going to be all the way up here. And then, if we cube 1/2, we get 1/8. Cube negative 1/2, we get negative 1/8. On the scale of this graph, 1/2 is going to be here. We subdivide the unit from 0 to negative 1. Half of that is going to be here. It's almost in the line that I used for the x-axis, and 1/8 is going to be just a tiny way below the x-axis. So it's going to be up here very close to the x-axis. And then 0, 0, 1/2, 1/8, 1, 1, and I haven't bothered to label the y-axis. Probably should have, and naturally when you do this you should. And then 2, 8. So the extended basic function is going to come up and make a pretty fast curve here. It's going to almost level off here. It's going to completely level off when it hits 0 for an instant before it then starts going back up. And you want to get all that detail into the graph in order to make estimates. Another handy thing to do, actually I'm not going to do it, I'm going to do it by relabeling, so forget what I was going to say. Well, there are the basic function graphs, the most basic functions. Make sure you graph them carefully so that you can do good estimates. Now I'm going to do a few estimates on a couple of these graphs, just to illustrate the process and geometrically, graphically show you how you would want to do estimates.